And we're live. All right, so good morning. Today is Thursday. You're probably wondering, why do we have a warm up today? Well, it's because we didn't do anything like that yesterday. And we're going to actually cancel the quiz for Friday. I know. On the one hand, this is great news. Okay, I know, right? Love and adore me. On the other hand, this is terrible news because now we have gone 2 weeks without a quiz, which means we have 2 weeks of material plus that'll be on your next quiz. Yikes. Super quiz, yes?
Wait, why are we canceling this one?
Because I read an email incorrectly the other day, and I thought yesterday I was going to have meetings during the second hour, which is my prep period, which makes so much sense. It's like, great, don't have to miss any classes. But I missed sixth hour, and I feel like it would not be fair if everybody except sixth hour took a quiz.
I get that.
Yeah, I feel like you would, right? You know.
Yeah, I appreciate it.
So that's the deal. But what this quiz will be over then is all of the remember like the trapezoid and stuff that we did, right? We had parallel lines intersecting. We had to find corresponding angles and find all that stuff. So all of that plus this, which is going to be quite a bit, plus a little bit more on next week. So let's talk about this. We know the standard form of equation by standard form. It's not really standard form. Capital S, F. Standard form is a different form of the equation. Mathematicians are stupid. But the equation you see most often for lines is this. And we know that this M right here stands for slope, right? And this B over here stands for the y-intercept, yada, yada, yada. Which means for number one, which we've already done, I know we've already done, the slope was 2. So M was 2. And the y-intercept was 1. When we go to graph this thing, we want to start with the y-intercept because it gets us a free point, right? There's our y-intercept at 1. And then from there, we can use slope. Remember, if you start from anywhere on your line, any point on your line, and you use slope, you'll be able to find another point on your line. Doesn't matter what point we're talking about. The reason we use this is because this is the easiest point to get, right? Bam, there's 1. So I go up 2 over 1, which is our slope here, right? Then I can find as many points on the line as I want. I can just keep doing that, right? Again, if I could start from any point and go up 2 over 1, I should find another point on our line. I can also do the reverse of this. Negative 2 divided by negative 1 is the same thing as 2 divided by 1, right? So that means I can go down 2 over 1, and it'll be just as good, right? Down 2, back 1. Which means without a ruler, we can kind of construct our line. So that's this equation, y equals 2x plus 1. It says in the directions that we want to make a parallel line to that. And not only will it be parallel, but it has to go through this point. And the reason they do that is because there are infinitely many parallel lines to this, right? Here's one, here's another, right? There are infinitely many parallel lines we could draw. They're all just lines that have the same slope, right? But there's only one line that is both parallel to this and goes through this point. And that point is here. I apologized yesterday for these being so close together. And so there's a point. And we know that if we want to make a parallel line to that, it's going to have the same slope, right? So we're going to go up 1 over 1 from that blue point. I'm sorry, not up 1 over 1, up 2 over 1, because our slope is 2. We can also go down 2, back 1, because that is equivalent. And we've got our parallel line. More or less. What do you think? I know we did it already. The question is, does it make sense? Or you smell when I'm stepping it? Okay, right. If they're parallel, the slope is the same. They specify a point. Start there. Use your slope, right? Number 2, we already did as well. This equation right here could be written as y equals 1x plus 0. That 1 in front of the x is important. If it was a 0 in front of the x, what's 0 times x? 0, right? Anything times 0 is going to be 0. So if there was a 0 in front of there, our slope was 0, bless you, x would not exist, right? The plus 0 on the end is, they just didn't write it because why would you ever write a plus 0? Enough! I was kind. So to graph this one, we start at 0 for our y-intercept, which is the origin. Then we go up 1 over 1. We continue to do this. This is the most basic of all the lines that aren't just perfectly horizontal or perfectly vertical. We can also go down 1, back 1, right? Because negative 1 over negative 1 is the same thing as 1 over 1. And there it is. There's our line. To do the parallel line, we need the same slope but go through this point. So there's 2 to the right and 3 up. Again, sorry for being so close. And then from there, we can just use up 1 over 1 again to make parallel lines.
Where did you go up from to get the one blue dot?
So the blue dot's from here. That's the point they give us. So they want a parallel line that goes through that point. I'm sorry? Even more? Yep. Again, the blue dot is the dot they wanted it to go through. And then to make it parallel, I used the same slope, up 1 over 1. So the purple is the parallel line. The red was the line y equals x. Let's turn the page. All right, next 3 aren't too bad. Before we do, instead of doing 3, 4, 5, let's just answer a little bit of each question and then go back to them. So what I mean by that is, looking at number 3, what's the slope? Negative 1, yep. Which is the same thing as negative 1 over 1, or the same thing as 1 over negative 1, right? You don't need to write all 3. I think it's just handy to have that, right? So there's the slope for number 3. Does everybody see why that's negative 1? Right, the last one was y equals x, and we could rewrite it as y equals 1x, right? This one can be rewritten as y equals negative 1x plus 0. Number 4, again, we'll come back to number 3. What's the slope for number 4? I will zoom in. What is the slope for number 4? Negative 2, which is the same thing as negative 2 over 1 or 2 over negative 1, right? All of those are valid slopes, however you want to think about it. Number 5, what is the slope for number 5? 2/3, which can also be written as negative 2 over negative 3, right? Depends on how you want to think about it. Going back to number 3, our y-intercept, b. What's the y-intercept for this equation? 0. So it's going to go through the origin, right? Number 4, the y-intercept is negative 3, this guy right here, right? So it's going to go through negative 3 on our graph. Y equals negative 3. Number 5, the y-intercept is negative 2. Very good. So it's going to go through negative 2. Again, the y-intercept just kind of adjusts where the line sits, right? The angle's set by the slope, and where the line sits on the graph is adjusted by the y-intercept, either up or down, right? Going back to number 3, let's use our slope to graph our line. So we already have 1 point, and we know that if we use slope from any point on our line, we can find another point on our line. We need 2 points minimum to make our line, right? So I've got the 1 point. If I use the slope, let's go down 1 over 1, down 1 to the right 1. We end up there. So now we can construct our line with a ruler, or you can just keep down 1 over 1, and we've got it. Same thing with up 1, left 1. That's what this guy is, right? Positive 1, up, negative 1 to the left. It's going to get us the same line. It's just a different way of looking at it. And there it is. Thank you for doing so quietly. Yeah.
Do you have to go that way?
This line? Yes, the direction is set by the slope. So when you do slope, it's going to be down 1, right? Over 1 to the right. So down 1 from one of your dots, over 1 to the right. Did you flip it? Yep, be careful that you go down 1 and then to the right 1, not to the left 1. Any of these will get you the same thing. That's why I prefer to write it as a fraction instead of this, because it helps me remember down 1 and then to the right 1. Or up 1 to the left 1. Same thing. We want our other line to go through 0, 4. So 0, 4 is here. 1, 2, 3, 4. Look, there's some separation there. That's nice. And we want the same slope. So down 1 over 1. Again and again and again. It's not a bad sketch. And they're parallel. So the purple line was our y equals negative x, right? And the blue line is our parallel line. Fun question. What would be the equation of the blue line? Y equals what? It'd be another negative x. But it's got to be different somehow, because these are the same equation, which means they should be the same line, and they're not. They're different locations. Plus 4. Right? Because it goes through 4 on the y-axis. It's this line, this purple line, the same equation, right? But moved up 4. That's what that does. Do you see the connection there? It's the same as the purple, so same equation, right? But it has plus 4 on it because it's moved up 4. The entire line is moved up 4. Let's look at number 4. So we have our y-intercept at negative 3. We're going to use our slope of down 2 to the right 1. So down 2 to the right 1. Again and again and again. Negative slope, so of course it's heading downwards. And there it is. Now we want a parallel line to negative, goes through negative 2 comma 1. Negative 2. In the x direction, I should say, and 1 in the y. Now the question is that blue dot on the line or is it not? Let's find out. If I use my slope, negative 2 over 1, from this dot I end up here. If I use the other slope, right, same thing, just different way of thinking about it, up to left 1, up to left 1 ends up here, up to left 1 ends up here. So what do you notice about that blue dot? It's on the line. So the line that's parallel to this and goes through negative 2 comma 1 is the exact same line. This is silly to draw it, but I'm doing it for a point. Ooh. They blended together very well, didn't they? That was cool to see. I have to go back and watch that on the feed. They're the same line. The line that is parallel to the purple line and goes through negative 2, 1 is the exact same line as the original. So both equations are y equals negative 2x minus 3. Cool. You might be like, wait a minute, are they parallel? They're constantly intersecting. Debatable.
Do you have to figure out both of the lines? Like,
You what?
do you have to figure out both of the x's?
Do you have to what?
Yeah.
No. Say it again. I just can't hear you.
Like, throw the y's, which figure them both out?
You mean writing the equations?
Yeah.
You don't have to write those. That wasn't part of the directions. I'm just doing that.
Okay.
Okay? Thank you for asking, Courtney. All right, next one. We've got our y-intercept at negative 2. We're going to use our slope of 2 up 2 over 3. Up 2 over 3 gets us to here, and I can keep doing that, up 2 over 3. I can also use down 2 left 3. And there's our line. We want a line that is parallel to that. And goes through negative 1, 0. Negative 1, 0 is here. So we are going to have some separation. They are going to be different lines, right? And if they're parallel, we want to use the same slope. So up to right 3, again, and again, and again. And they will be perfectly parallel if we don't screw up our dots. Down 2 to the left 3 also works. And there they are. And just for fun, because it seems like you guys are starting to get this, The purple line has the equation y equals 2/3 x minus 2, right? That's what they gave us. What would the equation of the blue line be? Well, they're parallel, so what do they have in common? Slope, right? So same slope, 2/3 x. But they're different locations, so their y-intercepts are going to be different. This one's kind of tough. Doesn't look like it intersects at a nice point. How do we figure that out? Think about what this means. 2/3 x. It means every time we go over 1, we go up 2/3 is another way to think about that. So if I go over 1, I've gone up 2/3. Another way to think of it. If I go over 2, I've gone up 4/3. If I go over 3, I've gone up 6/3. What is 6/3? 2. Do you see how that works out? Another way to look at the slope is just to say every time I go over 1, I go up that much. Every time I go over 1, I go down 2. Right? Isn't that what that says? Over 1, I go down 2. Just another way to think about it. So if I've gone over 1 to the right, I've gone up 2/3. So what's my y-intercept? 2/3. It hits it at 2/3. Let's put that away for now. Now we're going to do a warm-up. Where did I put it? No calculators. This is the warm-up. The idea is, how can you do this? How many different ways? Can you think of a clever way that would be easy to do in your head?
Is it
Rounding is a good way to go about it, right? You could say 0.5, right? Half of 921. It's not going to come out evenly, but it's still going to work, right? It can get you a good estimate. Can you get an exact answer? How many different ways can you think about going about this problem? Think creatively. Try to find a way that's really efficient. But even if you don't find a way that's efficient, try to find a way that's different, you know? For instance, Noah said round, right? Here's one way you could do it. You could say, look, I know if I find out this, which isn't too hard to do, wouldn't that get me this? It's one way to do it. These both aren't that hard to do. You might think that's hard. It's actually not. There's a way to go about that as well. Work together. I'll give you a couple minutes to work on it. Think about how you can do this differently. And if you're not sure, that's okay. Again, work together. By the end of this, hopefully we'll come up with some strategies of how to do this. Song of the day is by The National from their album, or his album, I suppose. It's a kind of a one-man band. From the album Sleep Well Beast. The song is The System Only Dreams in Total Darkness.
Maybe I listen more than you think, and I can tell that somebody sold you. We said we'd never let anyone in. We said we'd only die of lonely secrets. The system only dreams in total darkness. Why are you hiding from me? We're in a different kind of thing now. All night you're talking to God. The system only dreams in total darkness. Why are you hiding from me? We're in a different kind of thing. All night you're talking to God. And I cannot explain it. Any other way. I cannot explain it. Any other way. I cannot explain it. Any other way. I cannot explain it. Any other way.
Already listened to that one. What?
What was the answer? 'Cause I don't know if this is the right thing.
The correct answer? Well, let's do it this way to find out the correct answer. What's half of 921? Well, half of 900 is 450, right? And half of 20 is 10. And half of 1 is a half, right? So we're going to do 460.5. And we're going to subtract from that whatever this is, right? Well, I don't know what that is off the top of my head. But I do know that if I multiply it by 0.01 and add it to itself, how dare you guys? We get this. Right? Move the decimal place over 2. Same as multiplying it by 1, just with the decimal place moved over 2. So I get 18.42. When I subtract those two values, what's 0.5 minus 0.42? 50 cents minus 42 cents. 8 cents. 460 minus 18. We don't care about the 4. 60 minus 18. What's 60 minus 10? Now subtract 8 more. 42. So that is the correct answer. What other ways did you go about it? Luke.
0.48 times 100.
Okay.
Times 9.
Sure. Okay. So like that?
Yeah.
Okay. So 0.48 times 100. Well, if we multiply something by 1, it stays the same, right? Multiply something by 10, doesn't it move the decimal place over 1? If we multiply by 100, it moves over 2. So that's 48 times 9. How can we do 48 times 9 in our head? What's 50 times 9? 450. That's 2 groups of 9 too many, though. So we got to subtract 18. What's 450 minus 10? Subtract 8 more. 432. So we took care of this amount using Luke's method, right?
I get 0.48 times 20 plus 0.48.
Plus 0.48?
Yeah.
Ooh. Okay. So he knows that 0.48 times 1 is 0.48, right? That's where that comes from. 0.48 times 20, well, that's what he's trying to figure out. Right? So 0.48 times 2, what's 48 times 2? Well, it's 40 times 2, which is 80.
96.
8 times 8, or 8 times 2, which is 16. Add them together, we get 96. But we got to move the decimal place over 2. Right? And then we add 0.48. 96 cents plus 48 cents. Well, what's 96 cents plus 4 cents? $1, right? 1. Do you disagree? What do you have to say?
Shouldn't it be 9.6?
Why should it be 9.6? Think about it. 48 cents times 20. If I give you 20 like stacks of 48 cents, are you going to get 96 cents? No way, right? That doesn't make any sense at all. 0.48 times 2. Oh yeah, that's 96 cents. $9.06. Ah. What's $9.06 plus 40 cents? $10 plus 8 cents. Okay. Now we put these two together. 4, 4, 2, 0.08. Good. Yeah. That's one way to do it. Way to think outside the box. Think about what numbers mean. Any other ways to do it? No? How about this? What about this? Find out what 0.01 is of that, and then times it by 48, right? What's 0.01 of 921? Well, it's 921 because it's timesing it by 1, but move it over 2. Oh, yeah, my bad. What do you notice? Whoops, let's zoom out a little bit. What do you notice about this and this?
The same numbers.
They are the same numbers, except what?
Decimals in a different place.
So the decimal for the 921 is here, but I moved it over 2. And in order to balance that out, basically, I had to move this one, but to the right 2. Isn't that interesting? They're equivalent. They're the same thing. One has the decimal point here for 0.48. The other has it here for 9.21. They're going to be the same thing. So I can do 48 times 10 as an estimate and get 480, and it's a pretty good estimate, considering the answer is 442. So I can do 9 times 48 plus 0.21 times 48. 9 times 40, 360. 9 times 8, 72. 360 plus 72, 432. Do I agree with this? I do. 2148. Can I break that down into this? This is easy. 2 times 48, 96. Got any other ways? Hold on 1 second. And speak up a little bit because I can't hear very well. Like I've told you guys about that, right? I can't hear, especially out of my left ear, very well. What were you saying? 0.5 times 900. Say it again. Times 20 times 1. So our original problem was 0.48 times 921. See what we get. Well, half of 900 is 450. 20 times 1 is just 20. 450 times 2 is 900, times 10 is 9,000. She had a good thought process, but what went wrong? Luke.
Can't do it times 1 and then just cancel out. You have to add one of the numbers. So the times 1 just gets rid of itself.
So you're saying the times 1 is where she went wrong?
Yeah, she took one of the 5 times 900, 0.5 times 900 to make it times 1.
I think I know what you're saying. Are you saying that if she hadn't done the times 1, it would have worked out fine?
Well, if that was 21.
If it was 21, it would have. Let's try it. That's 450 times 20, which we already know is 900, or 9,000, right? And then 450 times 1, right? One more 450 gets us here. That ain't it. So that's not the mistake.
Is the mistake the times 20?
So if we do 0.5 times 900, we get 450, right? Which is pretty close to what we want. And it's an overestimation, right? Because she did 0.5. So Noah, what were you going to say? We don't want to do times 20. We want to subtract 0.02. Because we're at 0.5 and we want 0.48, right? We're already too big. We don't want to start multiplying anymore. So we need to subtract 0.02, times 900. And that's going to get us closer to our answer. Subtract that, we get what? 18. If we subtract 18, we get 432, which is much closer to this. It's not exact because we did 0.5 times 900, not 0.5 times 921, right? So we're going to add on half of 21, which is 10.5. We're going to get very close. Yeah. Put that away. Let's get that homework back out. The next bit of homework, 6, 7, 8. Number 6, what is our slope? These are the ones that are weird. What's the slope for number 6? It's 0. Another way to write this would be y equals 0x plus 0. Okay. So a slope of 0 is the same thing as go up 0, go to the right 1. Also the same thing as go up 0, go to the left 1. That's interesting. What's our y-intercept? Also 0. So we're starting at 0 on the origin. And we're going up 0 over 1. So if I do that, Starting at the red dot, go up 0. Okay, did it. Now go to the right one. And I can keep doing this. Same thing, I can go up 0, did it, and go to the left one. Fair enough. So this line is a perfect horizontal line. And that makes sense because the slope is 0, right? So the way I think about this is I think slope of 0, horizontal line, right? Where do you want me to put it? Well, I want you to put it at 0. Okay, at 0, horizontal line. Done. Now we want a line that's parallel to that. And that goes through 5, 4. Here's 5, 4. 1, 2, 3, 4, 5. Up 4, 1, 2, 3, 4. And if it's parallel to that, isn't it also going to be horizontal? Right. Ta-da! Did it. The blue line has the equation y equals 0. What's the equation of the purple line? First of all, what's our slope? 0, right? So 0x. We could write that out if we wanted to. I'm just going to not, right? What's the y-intercept for this?
0.
Not 0. Where does it hit the y-axis?
4.
It hits it at 4. Y equals 4. This is the point, or the line where every point on it has y equals 4 for its coordinate, right? We've got 5, 4 here, 6, 4, 7, 4, 8, 4, 9, 4. All of them have y equals 4, right? Here, everything has y equals 0. 0, 0, 1, 0, 2, 0, 3, 0, right? It's where all the y's are 0. If we go here, let's use that same logic. We want a line where all the x's are 0. So first of all, here's where x is 0 and y is 0. Zero comma 1 is where x is 0 as well, right? 0 comma 2 has 0 for x. 0 comma 3 has 0 for x. Do you see what this is going to make? Vertical line. All the points where x is 0. Do you smell what I'm stepping in? These are all the points where x is 0. So our slope here is vertical, meaning that we go up a number. Could be any number, right? We could go up 1 and go over 0. We could go up 3 and go over 0. It could be anything, right? We go up infinitely and go over 0. In other words, we call this undefined because it's dividing by 0. So our slope is undefined. We're not allowed to divide by 0. Right? And again, that divides by 0 means go to the right 0, which is what we do here. We go up some amount, and then we go to the right nothing. We go up some amount again, we go to the right nothing. Do you understand what that means? We go up a certain amount, and then we don't go to the right at all. That's what this means. Our rise over our run. No run. Just straight up. It's as steep as could possibly be. Infinite steepness, infinite slope, undefined. Infinity is not a number. 8. What does it mean? We want a line where all the what?
X's are on negative.
Yeah. So if we go to the x-axis, here's -2 on the x-axis. You're right. Now, where are all the points where x is -2? Well, -2 comma 1 is where x is -2. You see what I'm saying? This coordinate right here is -2 comma 1. This coordinate right here is -2 comma 0. Do you see how they're both -2 for the x value? We want a line where all of the points have -2 for their x value. Their y value doesn't say anything about, right? It could be any of them. But their x value has to be -2. Okay, so that's this line. What is our slope for this kind of line? It's infinite, which is not a number, so we call it undefined, right? We go over 0. Dividing by 0 is not allowed. Breaks math, so we call it undefined. page. Find the slope and equation of the given line, and then find perpendicular slope to the given line. So first off, we need to look at this line that they give us and write its equation. So this line right here, what does it look like the slope is of this line? The way we do that is we pick 2 points on the line. I'm going to pick these 2 points, and we find their slope. How much do I go up to get to this point? How much do I go up from here to here? 2. So a rise of 2. And what's my run to get to there? 2. Now there's a simpler way to write that, right? Yep, so that's our slope for the blue line. Sorry. If I choose random points on this line, I will get a different slope, right? I'll get something like, if I chose this point and this point, then I would say, oh, look, I go up 1, 2, 3, 4 over 4. And 4 over 4 is still the same thing as 1 over 1, right? So you can choose any 2 points on your line, figure out the change in the y direction, the change in the x direction, the rise over the run, and that'll be your slope. So we know that the equation is going to be y equals 1x. Now, what's the y-intercept for this guy? What's the y-intercept? 5. It hits it at 5. This is 5. So that's the equation of the blue line. Y equals x plus 5. Now we want a line that goes through this point and is perpendicular to that line. So we need perpendicular slope. How do we find perpendicular slope? What do we do? It's not going to be the same because that'd be parallel. What do we do? We flip it and negate it. So if I flip 1 over 1, what do I get? 1 over 1, right? But then I negate it and I get this. However you want to write it. Right? Any of those slopes are acceptable. So we know our red line is going to have a slope of negative x. Now we need to figure out what the y-intercept is going to be. Down 1 over 1 is our slope. Here's our point. Down 1 over 1 gets us this. So there's our line. What's our y-intercept? What's our y-intercept? Not 1, but negative 1. It hits the y-axis at negative 1. Do you see it? So the equation is going to be this. What's up?
I thought we were talking about the black dot.
No, 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 no. Try the next 2, and I'll see you tomorrow. Oops. That's parallel, not perpendicular. I'm a dummy.
I was confused on that.
I'm a dummy.
I was gonna say something, but then I
Yep,
was
yep.
doing the exact same, it's,
I did what you did earlier, where I went down 1, left 1, instead of going down 1, right 1.
yeah.
I blew it. Shout out to YouTube. Good morning, Ann. That's what we want.